Hello friends, welcome to our YouTube channel of series of basic process engineering calculations. In this session we will focus on how to calculate the water seal loop height to avoid the reverse flow in case of vacuum break or power failure or blower failure in case of scrubber. So this is a simple calculation. So we will just show you how to calculate the loop height based on the data or pressure differences available with you. So to calculate the loop height, we required density of fluids. Then we need the gravitational constant G. Okay. Then we need the pressure at one point towards the scrubber or towards the reaction side. So we will mention it as pressure at point 1 or the reactor side or scrubber, and second we mention like pressure at point 2 or reaction or process area. Okay, so based on that we can simply calculate the how much the height required to avoid the reverse flow in case of failure or vacuum drop. Okay, so to calculate we just considered water as a sealing media, 1000 kg per meter cube. Then gravitational constant is 9.81 meter per second square. Then we assume here that the at scrubber we have minus 34 m bar of pressure, and at reaction side or at process side we have minus 42 m bar of pressure. Okay, so in case of failure or power failure, the fluid from scrubber uh, may flow towards the uh, reaction or process area in case of vacuum loss. Okay, so we calculate that dp, the value required to break the water seal. Okay, so simply it is the differences between the pressure at point 1 and point 2. So we will simply this minus this. Okay, so we will have that much of m bar. We can convert that into Pascal by simply multiply. We convert that into Pascal or kg per centimeter square, because we have to calculate pressure P is equal to rho gh head or height of the static height required to avoid the reverse flow. Okay, to calculate the loop height or water seal level is equals to, we have P is equal to, it's simply P is equal to rho into G into H. Okay, so we have to calculate the H, so we can simply divide P by rho into g. So we will simply get the static head in meter. So we can convert that into mm by simply multiplying by 1000. We have that much amount of water seal or height of the loop required. So we can add some margin here with water seal loop height with margin of 20%. So we can consider it with 1.2, that is 21% mm. So the required loop height is simply 98 mm. Okay, so in this way you can calculate the loop height, whatever data you have with your as per your process requirement. Simply we can check here with some another example, like we considered at scrubber we have minus 20, and at process we have minus 160. Okay, so to break that much amount of vacuum or to avoid reverse flow, our required loop height is that, because the delta P is on higher side. Okay, so hope you understood how to calculate the loop height with the simply formula of static head, or that's pressure is equal to rho gh. So if still you have any query, you can drop me a message in comment section. We'll get back to you. Thank you.